Hello friends, I am Raghvendra. In this video, I am going to explain how to prepare bar bending schedule of a column. So this is a method to calculate the quantity of a steel reinforcement. On the screen, this is the complete format of a BBS. On the top of the page, you have to mention some project information like project name. You have to type the name of the project over here. Next one is client name. You have to type the name of the client. Next one is a contractor name. Type here contractor name if you are contractor side, so you have to write the name of your company. Next one is a tower name or location, then drawing number, bar length, grade of concrete like M40 or whatever is. Then next one is a structure like the ground floor to first floor column or whatsoever. Next you have to write the prepared by, and next one the checked by. After that the main format comes. In this format there is a serial number, description, dia of bar, number of bar, details of cutting length. In this details of cutting length there is a shape type A, B, C, D, which is a part of the cutting length. I have made a separate sheet for it, which I made all shapes which are supposed to come. In these shapes you can see U shape, L shape, straight bar, ring. In the ring A and B are dimension and C is hook. You can see the one leg ring, triangular ring. So now this, how you get the cutting length, you have to just add all these A, B, C, D part of the cutting length and deduct the bending allowances. Generally bending allowances is 1D up to 10 dia and 2D or above 10 dia. For the number of sets I have made a separate drawing for it. You can see that in this drawing there is a 4 number of columns which are C1. So in the number of sets you have to write the 4 over here. Now the next one is total weight. How you can get the total weight? Total weight, this unit weight is as per IS 1786 1985. In this 8 mm is 0.395, 10 mm is 0.617 and so on. So now there is a very tricky formula by which you calculate the total weight. In this formula you can see that it is a conditional formula, and in this formula if C12 is equal to M8, then D12 into K12 into L12 into M9, and you can see that there is a dollar sign also. Actually this dollar symbol is used to fix the row or column. If you put dollar before column, so column will be fixed but row will be free, and if you use dollar symbol before row, so row will be fixed but column will not be fixed. After putting this formula, just drag it like this and formula will be placed in every cell. Now to calculate the vertical bar, you can see that this is the column C1 230 by 300. Vertical bar is 6 into 16 dia. You can see that the placing of the bar 6 into 16 dia. So now write it, the dia of bar is 16 and number of bar is 6, and the VS is a vertical straight bar. This is a code, so just write it here. VS floor to floor height is 3.2. I just suppose that, and I mention here 3.2. so the total cutting length will be the 3.2 meter only. There is no deduction because there is no bending. Okay, next one is ring R1. Dia of bar is 8. You can see that in the drawing ring R1 is 8 at the rate of 125 center to center, and this is the section of column in which you can see that this ring. Okay, so now to calculate the number of bars, number of ring, you have to use 3.2 meter. This is the total cutting length of the column. So this 3.2 divided by spacing of the ring 0.125 plus 1. So by this method you can calculate the number of rings. This is the IS 2502 1963. This is the code for bar bending schedule. Here you can see that this type of ring, to calculate the cutting length of this type of ring, there is a formula 2 in bracket 2a plus e plus 24d. Okay, so by this formula you can calculate the, okay, so the one is 2 0 into 0.23 minus 0.08. there is a 2 covers. Okay, the next one is 2 into 0.3 minus 0.08. the C is 24 into D. And bending allowances, just because A and E was the internal dimension in the code, so to reach the internal dimension you have to deduct 4D here. Okay, now just add all these things and deduct the bending allowances. Number of sets will be the 4, and now automatically the total weight will come. Next one is ring R2. Okay, so ring R2, you can see that in the drawing, ring R2 is a type of one-legged ring. There is a hook is 12 dia, it is given in the drawing. Okay, and the spacing, you can say that the ring R2 is also 8 at the rate of 125 center to center. So ring R2 is 8 dia. Number of bar will be same as in the previous because the spacing is same, so the number of bar will be same. So 3.2 divided by 0.125 plus 1. So by this you can get the number of rings, and the shape type will be the R2. You can see that in the separate drawing R2, this is a type of shape A, B, C. There is a 3 parts. So A is a 12 dia which is mentioned in the drawing. B is the dimension 0.23 minus 0.04 into 2. The 40 is the cover, and the C is 12 dia, and there will be 2D deduction, bending allowances. The formula will be A plus B plus C minus bending allowances. Number of sets will be again 4, and now you get the total weight over here. So just calculate all these things, just sum of these 8 dia and 16 dia, you get the total weight of the reinforcement. This is 180.47 in kg, and you can convert it in a metric ton also by dividing 1000. I tried to explain it in a very simple language. I think now you can prepare the BBS with this attractive and presentable format.
If you still have any doubts, please write in the comment box. I will definitely reply you.